So my name is IRINA KAMALOVA. I'm senior software engineer in London right now. I'm working at IntelliJ Technology, and we build fintech product to store transaction data for financial services. And today I want to give you a brief introduction to Cassanda, Solr, and Kafka, because it's very powerful instruments, and probably you will find that you have some tasks that you could solve with that instruments, and I will be happy if it's so. And also it's very good to understand some NoSQL databases, and Cassandra is a good example for it. Also understand indexes, search indexes, and Solr is very good example for it. And Kafka is my favorite message queue. So let's start. Let's start with some business problem. And as maybe you know that Cassandra, it was created by Twitter. That's why I will show here the problem of storing tweets. So we can store tweets in Cassandra and write it at very, very high rate. And we can read it by ID. But what if we want to do analytic on these tweets? And what if we want to aggregate it by their content in text? And we probably need some solution with regular expression as we have in SQL databases, but we don't have it here. So again, what I will talk about is brief introduction to Apache Cassandra, brief introduction to Apache Solr, and a brief introduction of how we can integrate it with Apache Kafka. And first of all, we will start with Apache Cassandra. So what features you have from this NoSQL database? First of all, it's a peer-to-peer architecture. That means you don't have masters there. You have nodes that all equals with each other. It's good that you don't have a single point of failure. And it gives you elastic scalability. Why do I mean by elastic scalability? That you can easily add one more node to your cluster or remove one more node. So you can totally manage how many nodes in cluster do you have. Then data replication. So you can tune this parameter in your system. You can say how many nodes will store your data, how you can replicate it. For example, you have 5 nodes as at this picture, and you can say that your replication factor is 3. That means that 3 of these nodes, they will have this data for you. And you can be fine with tunable. So you can say also how many nodes you want to check when you read data, or how many nodes you need to wait to write data. This is called consistency level, and it's tunable. So you can say what do you want. You can even say level. You can even say that only one node is enough for you to read data. Maybe data will be wrong, but you need it to be fast. So what you will miss about? Cassandra means no joins. That means that if we look at this picture again, we know that data in different nodes. So if we want to join tables with each other, that means that we need to go to every node. That's too expensive, and it doesn't allow us with scalability that we want. That's why in Cassandra we don't have joins between tables. Also, you can do subqueries for selecting data. You can say, give me data where condition and select from the table, from the other table. As I said, no queries with like expression, so you can't analyze data. No commit rollback features. So yesterday we have a talk where it was said that Cassandra don't have transaction. That's absolutely right. You don't have transaction like you can say, okay, this is transaction. Now I need to save this data in this table, then to this table, then to this table. And if it was successful, I can commit this transaction. And if something was wrong, I can roll back this transaction. So in Cassandra, no, you can't do this. Then adding new column. It's one of the feature of the Cassandra. It's column-oriented and schema-free database. What does it mean? It means that if you want to add one more column to your table, you can do it, but not in these cases. You can't do it if your column is part of primary key. If it's part of primary key, you need to destroy whole table and create it again. If you already have terabytes data in this table, you understand the problem. You need to delete everything and create table and do full migration of all your data. So in this case, probably you just can't add new column because you can't wait for a week for data migration. So why it's happening? Again, if we look at how it's working inside, we will see that client can connect to Cassandra with driver application. That, of course, we have a lot of drivers and driver for Java. And when you connect to Cassandra, you connect to one node, any node. So, for example, it will be node 4, just random. And this node 4 is coordinator. And if you want to get data from all nodes, this coordinator will ask every node for this data, and you will wait for this answer, and you will wait for long. And suppose that you have 100 nodes in your system. So you will miss about insert with if exists condition. With this about transactions that we have in Cassandra. It's a lightweight transaction. It's called lightweight transaction. It's very funny because because it's not light and it's not transaction. But if you want to do if exist, something like in this example with your query, you can do it. You can say, for example, you need to save an ID, and that should save it only for one time. And you can do it. You need to say if not exists, and what will be under the hood. Under the hood, Cassandra will ask all nodes if they have data, and it's implemented by Paxos protocol. This protocol about that you have some leader, you have some steps, and you can apply your data in the cluster. So leader here is not that coordinator, and don't mess it up with master-slave system. It doesn't mean that you have master new system. No, it's a coordinator. So it can be any node in Cassandra. But when you perform Paxos protocol, In Cassandra, it extended that you prepare your data. They will tell you what data they have. You will try to apply new data, new state for your cluster. They will tell you if they applied, and after they tell you they applied it, it's already third step. You commit changes and get acknowledgement from them that data successfully applied every node, for every node. And that means that you have 4 round trips across the cluster. It's too expensive, so you should forget about it because it's too long and it can be with timeout. So you maybe can realize that, okay, probably that's everything that you have. It's possible to get to this model. For example, you have some data models that perfectly fit to Cassandra, but some data you want to do more complex query. As we saw an example, we have some text fields that you want to analyze. You want to see what's happening there. So here is example of a solution that you can bring here. It's Apache Solr. It's search index. So with one build on Lucene index, it's probably first search index that was implemented. It's Apache. It's used in production a lot. And what we have here, so Lucene index allows you to have full text indexing and search. I will not tell all details about Lucene index. I will not tell you how it's implemented inside because it's a term for one more talk. It's very interesting how inverted indexes are implemented and how exactly they allow you to find any information very fast. And all that you need to know for now that it's full text indexing that you can have. Also, it's REST-like HTTP and it's API HTTP. So if you're familiar with HTTP API, it will be easy for you to work with it, to debug it, to check it. Sorry. It have Java client. That's good because you can just get this client and it's easy to work with it. And a beautiful UI. I also mention it here because not every tool have beautiful UI just from the box. And for Solr, it's true. You can just download distributive for Solr and it will show you all inside Solr. You can easily work with it. So here is example. I saved some data here and you can see you just start Solr on your local machine and you can do some basic query like text, give me everything that contains the word in field text contain the word Google. And you can see it immediately in UI. It's very easy to understand Solr and it's very easy to work with it. Okay, what if I want more? I want cluster, of course. I want several nodes that will have my data. That's possible to search my data on several nodes. And here is, we already have solution, Solr Cloud. It's also Apache. It's also Apache solution, so you can use it for free. It's also have peer-to-peer architecture. It's have central configuration of the entire cluster in Zookeeper. It's automatic load balancing. So if you use Solr Cloud, you don't need to bring something like Ribbon from Netflix load balance client. You can just get Solr balanced client from Solr Cloud. It will tell you about all failures for the queries. You can be sure for if something goes wrong, you will have an error. And if you already have Zookeeper in your system, it's also good news for you because you can just bring it under your already existing Zookeeper. So integration for the cluster. And the data in Solr Cloud under the hood from the box, it's already replicated for you. It's already sharded for you, so you can say what you want to have there, how many shards, how many nodes. And it's also have UI for Solr Cloud. On my local machine, I just executed one node. That's why it's only one shard, but if you will have several of them, you will see everything. You will see how many CPUs they get, how many heap, and etc., etc. How many collection, how many replica. Well, this is probably what we need. Okay, we have Cassandra, we have Solr. We can write one application that just will get Cassandra data and put it on Solr, but we also want to be more flexibility. That's why we will use Apache Kafka there. And this let us also, for example, create event sourcing in our system. I will explain more there. So what we have in Kafka. Again, I will not tell everything about how it's implemented inside. You probably already heard about it, and I'm surprised that this is maybe the only presentation on this conference about Kafka, because it's very, very popular tool, and everybody trying to bring some news from it, and they implemented already so much features. They implemented a lot of clients, a lot of different Kafka Connect possibility to do SQL queries on it, and etc. How it looks like inside, you have Kafka architecture as a cluster and several brokers. Brokers basically store your messages, and you can push messages by several producers, and you can read it by serial consumers. And also it's a separate parallel consumption. Again, out of the box, you just can say how many consumers you want to be in your consumer group, and they will read your data from brokers, from topics in parallel. Data in brokers, they store in topics. And the idea also there is that you have publisher subscriber model. So publishers, they publish messages, and consumers, they are subscribed. And one more good thing that is something new there, consumers will get this immediately. So it's have high throughput. You can write to Kafka at very high rate. It's again elastic scalability. You can add more brokers to your system and you will be good. It's data durability, so you can say what is replication factor for your messages in Kafka. You can say it, and you can be sure that some data will be replicated, so you don't worry if some broker will fail. It's have So that means that you don't have single point of failure, and it have high availability. Like you also can bring it in different regions by geography, so your data you can get it faster. So how we want to integrate that all? With this just one of the example how they can be integrated. You can store your events, everything in Cassandra. Then you can notify Kafka what should be indexed, and then one more tool that you need to implement by yourself, and then you just put it in index. There is a lot of different architecture and different decisions. This is just one example how it can looks like. So if you use all these three components together, you have everything in peer-to-peer architecture. So everything is elastic scalability. You can add more nodes to Cassandra. You can add more workers to Kafka. You can add more Solr nodes into Solr cluster. You can be sure that data replicated at every point on this tool, and every tool you can be sure that data store on more than one machine. You can write at very high speed, at very high rate. It's that Cassandra lets you to do. You can guarantee that data will go to index search if they are in Cassandra. It's called eventual consistency, and you can be sure there. It's fault tolerance that you have there, and you have parallel search. Before we will go to questions, I want to show some examples here. I tried not to be too fast there, but I'm not sure that I could. So I will show you one example. First of all, I want to show here how easy it's to work with Cassandra. And then I will show you also how it's easy to work with other components. So let me just a minute to prepare something. Okay, that's probably too small fonts. So let it be here. Okay. I hope that font is good enough. Let me know if you can't see it. Also, so far, let me know if you have any questions. And let me check if there is something. Okay, if you have any questions, you can ask it. Okay, so first of all, I want to give a brief introduction how it's easy to start to work with the tool. So let's start with Cassandra. You can use Spring data, Spring Boot Cassandra, and you can very fast. You can be very fast to implement your first application of using Cassandra. So what will be here? So with the Spring Boot application, we have tweet repository. Tweet repository will store our tweet table with tweets. It's enough to say that it's Cassandra repository, and here as string we will have primary key. So we need to define the data, its entity table, and also we can separately we can separately define primary key entity. To simplify this example, I just said that, okay, primary key is just string. That's good enough. And our model, it will be really simple, just to show these tools. Okay, you have table, you have tweets. You can, so it's just a CRUD repository. You're probably already familiar with CRUD repository. It's give you all everything basics to work with database. So with this simple to work with Cassandra for just Spring. Okay, so let me do one more things. Let me show you that how you can, even with IntelliJ, so we discussed tools for development yesterday, and I will vote for IntelliJ because here I can connect to database, and I have Cassandra queries here as well. So I just need to define data source, say that is Apache Cassandra, say localhost, and say Keyspace. So let me, for this demo, delete this Keyspace. I will pretend that I never even created Keyspace tweets. And we will see. Okay, Keyspace tweets does not exist. Okay, so here we can write application, and also we can create Keyspace from Spring. We can do it with Cassandra configuration, and it allows you to create Keyspace without defines query for creating Keyspace. So you can say, if not exist, if it exists, it will not create new. You can say how many replica you will see, you will have there, and how many consistency level, what is consistency level will be. And let's do it. So I will create Keyspace. By my properties, it will call tweets. Then I will create several tweets. They will have just random ID, and I will say some simple messages there. So first of all, Google released new design for icons. Everybody knew it. I think everybody noticed. Then Apple released new operation system in 2020, and Google released the new search and features. Okay, let's try. I hope it will work. Okay, we see that it's print that it's found in table all tweets. And let's try again. Let's create new connection to Cassandra. So you can see content of the tables just from idea. Let's check. Okay. And here I can say, so query for Cassandra, even as Cassandra NoSQL database, column-oriented database, it's not, it doesn't mean that, oh, how I will work with it. It's just simple queries, like you can implement. So select everything from tweets and let's see what it brings us. Okay, it's there. We created it and saved data there. So suppose it is a component that save data in Cassandra. Now let's look a little bit at processing service that will put data in Solr. I will not show here everything, but what I want to show here, so yesterday one more great talk was about test containers. And I also will test containers. I really like this feature. And for example, for Cassandra, they have Cassandra containers. That means you can work with your data isolated in different Cassandra table, and you can write tests that will not interfere with each other, and you will be good there. Here is a simple example. You can define Cassandra container. You can say which version. Here I will use the latest version 3.11.12. Also, you just say get me cluster, get session, and you can execute queries here. So if I should create Keyspace, I could say the whole statement here, create Keyspace if it not exist. Okay, so we can create, for basic example, Keyspace here. We can test it, and we can check that our Cassandra have one Keyspace. And this is first simple example. And then you can basically execute all queries, like select from, like add, insert data, alter tables, etc. And all this you can do for your tests, and you will be really good here. I will execute it, but it will not bring a lot of unlocks. It just will say that the test was successful. The next thing that I wanted to show you while it's executing, it's Solr. Probably it's not so popular like Cassandra, but it's also very cool. And as when I said that you have Java client and you have API here, now I can show you how easy it's to work with that API. So Solr, we also have in test container Solr container. It's already there. We can create this container even with collection, and to connect to this container, you can say what Solr port you will get from here and what host. You just get it from container. So what we will do here, we will test everything. We will say that we create a new document. It will be Solr input document. And this document will be with ID. That will be UID. And the text, for example, this one. So then after we add data to our collection, we need to commit it because we need to commit changes. And here we can be sure if we want to use our processing data with Solr and Kafka, for example. In Kafka, we can say that we read message and mark it as a message that will not be produced by this consumer anymore when we committed our changes in Solr. That gave us eventually consistency. We can be sure that we will process data. If we didn't, for example, if we failed to save data in Solr, we can say to Kafka that we need to process this message again. That's why Kafka gives us a powerful instrument to store data there, to store messages there. So we can query data from Solr. This query gives us everything, and we can check results. This test allows us to see these results and assure that this is documents that we expecting. And also we can delete everything by query, for example, or if we know ID of the document, for example, here we defined it, we can delete documents by ID. And it's also possible for us from Solr API. Here I can start this test. And also I want to show you how it's look like in Solr UI. Let me go to my host and play this data a little bit there. Okay, I hope it's not too small. Let me know if it's too small. So here I have tweets. This is collection that I prepared for today. Basically, when you define collection, you can say what schema you will use here. So, for example, in this tweets collection, I have ID, I have text, and I don't need anything more. I can execute query there, and you can see everything that Solr index store. For example, right now here is 3 tweets, and if we want to analyze it and search something by, for example, everything that contain Google, right? I can do it like this, and I filtered everything. It's a full text search. I can say give me tweets that contain only 2020, and I can say give me only Apple tweets. So like this, I can analyze what is more popular in Twitter was in 2020, for example, and and 2020. So okay, that's really easy. And everything you can do from Java API. You can say what documents you want to add. You can say what query you want to see. You can, so here you also could say, give me all text that contain anything. And you can create it in more complex way. And you can delete the documents, and you can also tune commit. For example, you can say, bring me commits every 10 seconds, something like this. It's all tunable. And as I said, we can also we can store data in Kafka before we push it in Solr. So I thought that I will not have enough time to show everything, but again, you can use test containers for Kafka, and in these containers, you even can create topics. You can say how many partition you will have there. Why it is important? Because you can consume in parallel from Kafka, and how many partition you will have. This means how fast you can consume from Kafka. How many processes parallel can consume from Kafka. Consumer group, they can be in one application, or you can create several instances of your application and they all will be at the one consumer group. Replication factor that you can also define for every topic. And in test container API, you can also delete topics. And about consumers and about producers. So in this small example, you can define Kafka producer. You can say what will be key for your data. For example, if you create several partitions in your topic, you can say how they distributed by several partitions. And it could be by default, it will be just next partition, or you can define partition key. And you need to be careful here because your partition key should give you good distribution. Then you need serializers. You can use default serializers from Kafka if you have your data very simple, like strings or UID, or if you have for longs or etc. If you create your inner entity like tweet with different fields, you need to implement your serialization for this entity. The same, you need to deserialize your data. And if you implement all this, you can use it. Also, you can define when you will start to read data. For example, if you want to start, if you want to read everything from start, from the beginning, you can say, give me data earliest, or you can say, give me latest, give me only new updates in your system. Then you just produce data from producer. It's only one method send, and then you can consume it in internal loop. And you can tune a lot of components, like you can wait for new messages, you can consume it by batches, and you can tune a lot of performance. What else I wanted to show you? So again, here you can be sure that your data, you have data in different nodes. You can replicate it. You can be sure that they will be stored here. They are durable. Here you can also replicate your data. You can use several consumers to consume data, and also you can replay data. If you want to read data to save new data from Kafka, and you should be sure that all your data saved, you can do it everything very easy with Kafka, with tuning your level of how you, when you notify Kafka that you okay with messages, you can read next messages, or you need to reread this message again. And here you also have, you can have cluster, you can have several nodes there. Data can be replicated, sharded, and you can easily work with it. For all this, for performance, you have there is already implemented dashboards for Grafana. So you just add Prometheus to your system, and you can easily do monitoring for all these components. And that means that you can tune your integration. You can tune your performance. I hope there was not too much information, and it was aggregated. So if you have any questions, please let me know. Also, it's easy to follow me. I have almost the same nickname everywhere. So please follow me and motivate me to write more about these components, or open more questions on these terms. I hope that you enjoyed this.
Irina, it was a great presentation. I have a question actually for you. How big was the biggest Cassandra cluster that you have worked with in production?
Right now I'm working with clients, and they have, I don't know how many nodes they have there, but it's about, we're waiting for clients that have 40 terabytes of their data. I think there is a lot of nodes of Cassandra. I'm not sure how many exactly, but it's a good question. For testing, we use a small cluster of 6 nodes, and we do performance testing on it. I mean, we put there a lot of data on high speed rate, and we wait for good results there.
Sounds like a lot of fun. Gigabytes, terabytes is not a small number. Okay, I don't think we have any questions from the people. So thanks again for your presentation.
Thank you very much. Thank you for everybody who was there to the finish. I hope you enjoyed.
Yes, and you can listen to Irina in the presentation that's upcoming next about women in software development industry, challenges, career, leadership. And see you there. Bye.
Bye. Bye.